Section 12.1.4 is titled, What is the Reciprocal? And the subtitle is Reciprocal Trigonometric Functions. By the end of the lesson, you will be able to graph reciprocal trigonometric functions and solve equations involving these functions. So your team will investigate the reciprocal function of y equals the cosine of x, written as 1 over cosine of x. And there's a resource page that I put in your packet that will help you, that'll give you a table and help you graph it. So we're going to go to 12.1.4c on the resource page and write the values of x into the x column on the table. So you're going to flip over a few pages to the page that looks like this, that is titled 12.1.4c resource page. And then you're going to grab your unit circle, and your unit circle is going to help you fill in the values for the cosine of x. So you're going to start filling in the x column all the way from 0 to 2 pi. Go at least in 1/4 pi increments. And then the cosine of x is going to be at 1, at rad 2 over 2, 0, and then fill in all the rest of them that I started for you. And then the next direction says that you are going to use the unit circle. Told you that already. Make a careful graph of that y equals cosine of x. Make it as nice as you can. And then you're going to label the third column 1 over the cosine of x. And you're going to calculate the reciprocal value of the cosine of x and write your answer in the third column. Okay? So the third column looks like this. You're going to calculate those using your calculator. And when you get to pi over 2, your calculator is going to give you an error. Part 4 says, where are the values for cosine of pi over 2 and cosine of 3 pi over 2 located on the graph? That's going to be where your x-intercepts are at. And what is true about the reciprocal values of these locations on your table? They're undefined. Your calculator is going to tell you error. Okay, and how will that appear on your reciprocal graph? Well, that's going to be where your asymptotes are at. Asymptotes are imaginary lines. We usually dash them in that guide us and show us where our graph is going to get really, really close to, but never actually touch. Okay, so you're going to carefully graph the 1 over cosine of x. You can either use a different color or you can use a highlighter, but you need to have both of them on the same graph together. They should roughly look something like this. I did my regular cosine of x in green, and I did the 1 over cosine of x in blue. So yours should come out looking something like that. If you type them into Desmos, that's how you would type them in. The reciprocal of cosine is called the secant, and the secant function can be abbreviated as y equals the secant of x. And you're going to title or label your new graph with the name secant. For question 52, we're going to answer some questions about the graph of y equals the secant of x. So first of all, they want to know what is the domain and range of y equals secant of x. So the domain is going to be all real numbers except multiples of pi over 2. And then the range is going to be from when y is greater than or equal to 1 or y is less than or equal to -1. Part B wants to know what are the x and y intercepts. So there are no x-intercepts, but there is a y-intercept at 0, 1. And then are there asymptotes? Yes, there are definitely asymptotes. And where are they at? They are at pi over 2 and all of its multiples. So every time you get to a multiple of pi over 2, there's going to be an imaginary line where your graph is going to approach but never cross. Okay, so describe the relationship between the graph of y equals the cosine of x and y equals the secant of x. So each x-intercept of the cosine graph is an asymptote of the secant graph because 1 over 0 is undefined. Question 54 wants to know, is there an inverse secant button on your calculator? So no, there is no inverse cosecant button. So how can you calculate or solve for the secant x being equal to 3.5? You're going to use 1 over the sine of x. Question 55 says, the graph of the table of the reciprocal function for sine of x is called the cosecant and abbreviated as y equals the cosecant is shown below. It's actually shown here and a little bit bigger right here if you need to see it. And then they want to ask the similar questions of what we saw for the inverse of the cosine. So they want us to look carefully at the graph and answer the following questions. What is the domain and range of the cosecant? So the domain is going to be all real numbers except for pi and its multiples. So every pi, roughly, there is going to be an asymptote. And the range is going to be from 1 when y is greater than 1 and less than or equal to -1. What are the x and y intercepts? There's no x intercepts and there's no y intercepts. It kind of looks like it's going to get to it right there, but no. There's an asymptote and it's not going to touch it. Part C says, are there asymptotes? And if so, what are their equations? So yes, there are asymptotes. Every multiple of pi. We could spend a lot of time writing them, but we're just going to abbreviate it as multiples. And then they want us to describe the relationship between the graph of y equals sine of x and y equals cosecant of x. It's pretty much the same as the other one. Each x-intercept of the sine graph is an asymptote of the cosecant graph because that's where the graph is going to be undefined. For question 56, you're going to work in your teams of 4 for each of the following equations. Work with your team to decide if the equation is always true, sometimes true, or never true. If always true, explain how you know. If sometimes true, give the exact values of x that make it true. And if never true, explain why it is never true. So you're going to do A, B, and C together. And then make sure you read the math notes box together at the bottom of page 15. And then you can go ahead and complete assignment 12.14 on the review preview.